Today, we're going to pull back the curtain on the invisible forces that literally build our world. We're talking about the bridge you cross on your commute, the device you're holding right now, and the clean water that comes out of your tap. This is the story of how abstract science becomes the reality you live in every single day. Seriously, just for a second, wherever you are, look around. Think about the room you're in, the screen you're watching this on, even the lights making it all visible. Every single one of those things, the bridge, the screen, the water, we just expect them to be there, right? We take them completely for granted. But they're not accidents, and they're definitely not magic. What they are is the result of applied technology. That's really just a way of saying it's the practical, real-world expression of scientific knowledge. It is the engine that has built and continues to build our entire modern world. So, who are the people turning all this science into stuff we can actually use? Well, let's call them what they are. The world builders. They're the professionals who take these abstract ideas and make them tangible.
So let's be clear, technology application isn't just about the newest smartphone. It's this whole process of taking what we know from science and using it to solve a real problem. Like, how do you get power to an entire city? Or how do you find the resources we need buried deep in the earth? It all comes down to making life better, safer, and more efficient.
And you've really got two key players in this game. On one hand, you have engineers. They're using physics and math to literally build our world, from giant skyscrapers all the way down to the tiniest microchip. And on the other hand, you have geoscientists, who use earth sciences to understand our world, finding the stuff we need and protecting us from what the planet can throw at us. They're two sides of the same coin, both turning theory into reality. Okay, so we know who does it, but how does an idea actually become a physical thing? It's not just random inspiration. There's a very specific professional process behind it all.
Which is a great question, isn't it? How does that happen? It's not some sudden flash of genius. It's a methodical journey, a step-by-step path from a problem to a solution that you can actually touch and use.
And that path usually looks something like this. First, you identify a need. Let's say a community doesn't have safe drinking water. Okay, problem identified. Next, professionals develop a solution. They design and test a water filtration plant. Then comes implementation. They actually go and build the thing. But, and this part is absolutely crucial, the job isn't over. The final step is to monitor it for the long haul, to make sure it keeps working safely and reliably for years to come. It's a whole cycle of responsibility. These days, problems are way too complex for just one person. Think about building a massive hydroelectric dam. You can't even start without geoscientists making sure the ground is stable. Then you need civil engineers to design a structure that can hold back millions of tons of water. Then you need electrical engineers to actually make the power. And all of that has to happen while environmental scientists manage the impact on the ecosystem. It's a true symphony of different kinds of expertise. All right, so when these teams of experts get it right, the impact is, well, it's huge. It's not just about finishing one project, it creates this massive ripple effect across all of society. The most obvious ripple is economic. When an engineer figures out a more efficient way to manufacture something, or a geoscientist discovers a new source of energy, that single breakthrough can power an entire nation's growth, create thousands of jobs, and sometimes launch whole new industries. But it's also deeply personal. It's about your quality of life, the safe roads that get you home, the clean water that keeps your family healthy, the communication networks that connect you to anyone, anywhere in the world. These are all direct benefits of applied technology. And today, there's a really critical shift happening in this work: sustainability. The goal isn't just to build anymore, it's to build responsibly. That means pioneering renewable energy, designing systems where we reuse everything, and just fundamentally making sure that what we create today doesn't mess things up for the world of tomorrow. Which brings us to a really, really important point. Because having the power to shape the physical world, well, that carries an immense weight of responsibility. Because with all this incredible power to do good, there's always the potential for things to go very, very wrong. So, what's the catch? The catch is ethics. This immense power comes with a duty to the public that you just can't negotiate. It means putting safety above everything else, because people's lives are on the line. It means thinking about equity, making sure the benefits of tech don't just go to a wealthy few. It means protecting our privacy in a world that's more connected than ever. And it means being totally transparent about risks. These aren't just nice ideas, they are core professional duties. And the reason why is because the stakes could not be higher. When those ethical duties are ignored, the consequences can be nothing short of catastrophic. Whether it's through neglect or on purpose, misuse can lead to devastating environmental damage, financial ruin, or, worst of all, human tragedy.
So, with that heavy responsibility in mind, what does the future look like? Because technology never stands still, and the next big wave of innovation is already here, and it's changing absolutely everything.
This gives us a pretty amazing snapshot of that future. You can see the biggest driver by far is digital. We're talking AI and the Internet of Things. Right behind that, you've got clean tech and renewables. And what's really fascinating is how these fields are all starting to blend together, creating even more powerful possibilities. This is what's going to shape the next decade.
And look, this isn't science fiction stuff. It's happening right now. We're putting smart sensors on our bridges to check their health in real time. We're using AI to predict and prevent dangerous accidents in mines. And we're using incredible modeling to manage our resources better and prepare for natural disasters.
But just as we've been saying, every powerful new tool brings brand new challenges. Things like cybersecurity risks or the really complex ethics of AI. It just hammers home that core idea. Innovation and responsibility are not separate things. They have to move forward together, completely hand in hand. And that really brings us to the final and most exciting question. We have built bridges, we've harnessed electricity, and we've connected the entire globe. So now, with these incredibly powerful new tools and a deep, unbreakable commitment to responsibility, what amazing problem will we solve next?